So now that we know some of the basics about how to convert units through the different systems, we can begin to talk about how we can do some problem solving with more complex conversions, or actually having to do some math. There's a big ol' heart at the beginning of this video, and I feel like the reasons for that are self-evident. So here's an example problem. How fast do you travel if you go 25 miles in 2.00 hours? Now we all know immediately that the answer is 13 miles per hour, obviously. But if we didn't know that, how would we do it? And this is again one of those problems that seems really easy. Why are we doing it? Because we can do it in our heads. But there will be more complicated problems later, so we need to know the process. So first thing we want to know is, well, what formula do we use? So distance equals rate times time. That's a problem solving formula that you've probably seen before. And again, we choose a really simple example that you're well familiar with here so that we don't overly confuse you. Remember that we're going to use the simple to learn the complicated. So we have d equals r times t. That means distance equals rate times time, and d, r, and t are symbols. Now this is very confusing for people a lot of times. At first we talk about symbols versus units. The symbol here that we are using for distance is d, for rate or velocity is r, and for the time is t. But those are not the same thing as units. Our units are not d, r, and t. You wouldn't say, how far did I go? Well, I went 25d. You would say that I went 25 miles. You would say I went 25 so many miles per hour. And you're talking about hours. So you have symbols, d, r, and t, and units, miles per hour, miles and hours. That's going to be important as we go forward. So now let's go ahead and solve it. How fast do you travel if you go 25 miles in 2.00 hours? So we have to rearrange the formula to get the variable that we want all alone by itself on one side. We're going to use algebra. Yay! So how do we do that? Well, what is the variable that we're wanting to solve for? The variable we're wanting to solve for is how fast. That is a rate. We want to solve for rate, so we want to get r by itself to one side. So how do we do that? Well, this is basic algebra. We want to we realize it's not by itself because it is being multiplied by t. So we do the opposite operation to it. What's the opposite operation of multiplying by t? Well, it's dividing by t. So I'm going to divide r by t on that side to cancel my t's. But if you do it to one side, you have to do it to the other, and now we see that the t's go away, and we're left with the expression r equals d divided by t, and that's algebra. So now we know that r equals d divided by t. That is what I saw there. Yeah, there we go. So what next? Well, what's next is we're going to do the math, but when you do the math, you cannot leave out the units. This is one of the primary differences between this class and a lot of the classes you've taken in the past, is that you probably don't focus too much on units when you're doing math, but we really need to be careful. So we have r equals d divided by t, so let's plug in what we know. We know that we have 25 miles is our d, so we plug that in on the top of our chart, and we knew that the time was 2.00 hours, so we plug that in on the bottom of our chart, and then just like before, anything on the top of the chart we're going to multiply, anything on the bottom we're going to divide. Now there's only one thing on the top, so there's nothing to multiply, so we just end up with 25 divided by 2. But we also haven't looked at units. The units are miles divided by, remember that slash means divided by, hours. So miles divided by hours is our unit, which is what a mile per hour is. So not only do we have 25 divided by 2 as our answer, but the unit is miles divided by hours, which is how we get 12.5 miles per hour. Of course, once we use significant digits, we're going to round that to 2 sig figs, which means that our actual answer is 13 miles per hour. So that's a pretty simple example, but what if the problem had not been quite so easy? What if we had had a slightly more interesting question like this one? How many days would it take to go 3,500 miles at 15 meters per second. This is a problem that you probably cannot do in your head like you could do the last one perhaps. So how are we going to do this? Well, the process actually doesn't change from what we just did. We just have to be a little bit more careful with our units. Everything that we just did we're going to do again. But what did we just do? What was the process? Well, the first thing that we did was we rearranged the formula to find what we were looking for, to get the thing that we were looking for all by itself on one side. And the second step, we plugged the things in that we knew into the chart. Anything that was times we put on top, anything that was divided by we put on the bottom. And so we're just going to continue to do that. And the last step, we converted the units until we have what we want. Now, I'm not sure how helpful that list is. You really kind of learn this by example, but that's the general flow. We're going to rearrange the formula, get what we want on one side, plug the things in we know using that formula, using the chart, and if any of the units don't cancel out to give us what we want, we have to convert them. So what does that look like? How many days would it take to go 3,500 miles at 15 meters per second? Well, what was our first step? Rearrange the formula to see what we're looking for. So the question is, what are we looking for? We're looking for days. Days is a time. So we're looking for time. In other words, we want to get time by itself on one side. So why isn't time by itself right now? Well, because it's being multiplied by r. So what's the opposite operation of multiply by r? Divide by r. But anything you do to one side of the equation, you have to do to the other side of the equation. The r's cancel, and if we rewrite this, we find that t is equal to d divided by r. How useful is the algebra? It's amazing. So t divided by r is the formula that we want to use. So we're going to go ahead and we're going to plug that in using our chart. We're going to use it's a dimensional analysis chart, just like it's always been, but now we're going to do some math with it. We're going to use this as our guideline, t equals d over r. We're going to plug things into that formula, keeping in mind that d's go on top and r's go on the bottom. Now t we don't need to plug in because that's what we're trying to solve. You only plug in the things that you're trying to find, or the things that you know. You plug in the things that you know so that the chart will spit out the thing that you don't know. So the point is you find the thing that you don't know by plugging in the things that you know. So let's go ahead and do this. Well, it says that we need to find t, we need to take d and divide it by r. Well, d is a distance. What is our distance? 3,500 miles. So we plug in 3,500 and we plug in miles. We cannot sleep on our units. So you got to have the units. Okay, so that's done. Check. And then the next thing it says is that we got to divide by, slash means divide by r, and r is 15 meters per second. So we have to put 15 on the bottom. However, what do we do with meters per second? Well, let's go back a minute and look at what miles per hour looked like on a chart. It looked like this. We just had miles on top and hours on the bottom, and we read this as a per. So miles on top with hours on the bottom is miles per hour. So it should look similar to that, only now we are looking at not miles per hour, but meters per second. And this is important, this is really important, we are not finding r now. R is in the denominator. R is in the denominator. The meters per second starts out on the bottom. So earlier we started with miles on top divided by slash to the bottom hour. But this time, since it's being divided by, we're actually starting on the bottom. So what do we do with the hour? Well, you don't put a slash here. That's wrong. You do not put a slash there. You never, ever, ever put a per into one of these charts because the chart has the per built in. What did we do earlier? Whenever we wanted a per, we just flipped to the bottom. Well, what if we're already in the bottom? Well, we flip to the top. So meters per second is going to look like this. There you go. That's how you would write divide by 15 meters per second. If we were timesing by 15 meters per second, we would have written the same thing, only flipped. So whatever you start with goes on the top if you're multiplying, bottom if you're dividing, but then you slash or a per means that you flip to the other side. Now that was just what we would have done, but that's not what we did. That's not correct. We want to leave it like that. So we have 3,500 miles divided by 15. Now if you look at the formula, you'll realize we're done. We put everything in. We want t, we put in d, we divide by r, so you take 3,500 divided by 15, and you get an answer, but that answer is going to be wrong because the question says how many days. Now here's one of the beautiful things about one of these unit dimension charts. When you're done, if you did it right, the only unit down here that will still be uncancelled is days. Well, that's not true right now. Right now, nothing cancels. We have miles here, we have meters here, those don't cancel, and we have seconds on top. So we need to get some cancellations going here. And so the first thing that I want to do is I want to get rid of this miles thing. Well, just like before, how do we cancel things that are in on the top? Well, we write them on the bottom. Now, the adjacent part, the cell right here, is already taken, but that's okay. We can just move on down here and write miles over here. As long as it's on the bottom, it'll cancel. It doesn't matter left, right, where it is. So we want to get rid of miles, and we can, but we can't do that unless we have a conversion factor. So we need miles to what? Miles to what? Well, how about meters? We got meters here because if we put meters on the top, you'll notice that we can cancel both the meters and the miles. So if we know meters to miles, we can just stick that in there. Well, what is meters to mile? Well, it's 1,610 meters is 1 mile. And so if you look here, you'll see that all of the units, just by putting that conversion factor in cleverly in the right place, we were able to get everything to cancel out except seconds. And that's good because the answer needs to be in days, and we already know how to convert seconds into days. We're going to first convert seconds into minutes, and then minutes into hours. So I'm going to put seconds on the bottom. I'm actually going to go straight seconds to hours because I happen to know that, and I'm going to run out of room if I don't. If you want, you can go 60 and 60, but I'm just going to take 60 times 60 is 3,600, so I know that there are 3,600 seconds in 1 hour. And now my seconds are canceled. And now, again, keep in mind the target. We want days. We know how to get from hours to days. Hours to days. 24 days is 1 hour? I don't think so. How about 24 hours is 1 day? And so now, if we go back to the start, we can see the oh, the humanity. So everything canceled. We used the formula. We plugged everything in. Everything, all the units went away the way we wanted to, except days. Days is what we want the answer to be in, and so we're really, really happy. We know we've done something right. So now all we have to do is, just like we did with our unit conversions, we have to multiply things on the top, divide by things on the bottom. So 3,500 times 1,610 divided by 15 divided by 3,600, or if you like, divided by 60 divided by 60. And then we're going to divide by 24, and my calculator says that the answer is 4.3479 blah 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 blah. So I go back and look at sig figs. Looks like there's 2 here and 2 here, so I want 2, so 4.3 days is the answer. And now I've done a complex unit conversion problem, and now I can do that with all sorts of formulas because now I know the basic steps of how you would make things cancel out the way you want them to.